So hi everyone, welcome. I'm Daniel Coupal. I've been at MongoDB for close to 10 years now. I currently help our strategic account customers with their data models. Some of you may know me from my blogs on schema design patterns or anti-patterns, the MongoDB University data modeling course, or numerous presentations like this one. One common thread, I'm passionate about data modeling from MongoDB. It's been a busy year for MongoDB. We just unveiled a ton of new features for the server and data platform, from tools to help you migrate your relational databases to MongoDB, to the ability to store information from artificial intelligence tools like ChatGPT as vectors in Atlas and be able to do queries with that. You're likely to find something exciting. As for me, much of this year's excitement comes from this book. The story began when I heard through Steve Oberman's newsletter that he was writing a series of books to which MongoDB would be the first one, a collaboration with Pascal Desmarais. The thing is, I've known Pascal for years, so I sent him an email, congratulate him on his collaboration with Steve. At that time, I was also writing my book on schema design. It took Pascal no time to convince me to join them. The collaboration was fantastic and speedy. And with Steve, we inherited someone who had published a dozen of books, so someone who knew how to do that. Within 6 months, I adapted my content, written a new section, and I had a printed book in my hand. There are a few times in life when you get this incredible lucky moment, and for me, that was such a moment. So all of you get a chance like this for something you dream. If it happens, just jump on it, take it. The main lesson I learned from that is to partner with people who complement you, but also overlap enough that you can have good discussion and progress on whatever you're doing. So with that, let's talk about data modeling. So our presentation will be divided into 3 sections. We'll start by looking at the need to model for MongoDB and for all NoSQL's database. And then we'll describe a technique to model specifically for MongoDB. And then we'll discuss a little bit more the third phase, which talks about schema design pattern. More specifically, we'll talk about the schema versioning that let us evolve the model. So we have a lot to cover. Let's get going. So the first thing I like to say is we need to model because we have constraints. If there were no constraints, you wouldn't have to model. For example, when you breathe, you don't have to think about how you're going to get air in your lung. There's an abundance of it. It just goes through. Now, if you were on the space station, it would be something different. When we do system for computers, the problem is there's a ton of constraints. So we need to understand them. If we understand them, we are in a better position to understand why we're doing certain choice in our model and putting information together on disk and RAM, etc. So you get constraint like physical constraint. The network speed is not infinite. If you put your data closer to your the database, closer to your application, things will be faster. The database at the end of the world, it's going to take a little bit more time. So these are given. You have to deal with that. We get a lot of constraint from hardware. These are probably the most important ones to understand why we model certain ways. So we tend to put things in RAM that we want to use very often. The rest is going to go on disk. Disk is cheaper, but it's slower than RAM. So that's the compromise that you get. And then finally, there's a lot of constraint that's going to come from the software you're using. So if you're using MongoDB, there's maximum size for the documents. But there's also the fact that there's features that we have in MongoDB that's going to influence how you model. If the feature doesn't exist, you'll have to do things differently. So out of that, we get our first principle for this presentation. We model to face and answer to constraints. So when we look at an application, we talk to MongoDB. MongoDB resides in some hardware. What's going to be interesting, obviously, for us today is what we have in MongoDB. When I joined the organization, there were a bunch of features in MongoDB, like the document model, indexes, sharding, replication. And with time, we started adding things like transactions, field-level encryption, queryable inscription, federal data federation, archives. The point I want to make here is some of these things didn't exist. We had modeled differently. For example, before we had transaction, we would tell the customer you can still do it by doing a double commit. It's not fun, but it was there. Now we do have native SQL-like transaction. They've been there already for something like 5 years. Another example will be field-level encryption. You could always encrypt, manage all your keys, but it can be like really complicated. Now, MongoDB's feature, field-level encryption, is really like the best encryption feature you can find out there. But once you know it exists, you can also use it for your model, etc. for data federation archives or searches. Now that MongoDB allows you to do text searches, you don't need to deploy a Lucene-based search engine next to MongoDB and sync those. So the point I want to make here is that it's imperative to know the features of the products you use. So that's going to help you design your things correctly with that. So for this presentation, we're going to use a little example. It's a social network for chefs. So we're going to have chefs that write articles. We're going to take the articles, categorize them, put tags on them. And then we're going to get also a bunch of users going to come and read the articles, recipes, and then you're going to comment on that. So very simple model. If I ask you to model that for a relational database, you're likely to come with that solution here where we have people that write one or many articles. They also write one to many comments. We have one to many comments associated to an article, etc., some information that's tagged. So the point here is that there's only one solution you get when you model that and you want to respect the third normal form. So it's pretty easy to reach it. You know, pieces of information, they have a one-to-one, one-to-many, or many-to-many relationships. Once you identify them, they're going to go to the right place according to the relational theory. Now let's go to MongoDB. I ask you to model the same thing for MongoDB. So if the main entity that you're doing queries on, your concern are things that you have to return, are articles, that will probably be your main collection. And then you could put all the information in it. You could put the tag, categories, the comments, and also the people who are writing the articles. Now, if you do that, you're going to get duplication of information. Someone who's writing many articles will appear in many of them. So you may say, I don't want to deal with that duplication, so I'm going to extract this entity, put it aside, create my relationship, and then I'm going to have two collections. So the question here is which one of these two solutions is the best? Well, it's not obvious. If you really don't want to deal with data duplication, it would be the one on one side. And if you're okay to deal with data duplication because you really need to meet these very tight SLA in returning the information very quickly, you probably will be doing one read instead of two reads, you'll probably go with the other solution. So here again, the next principle is the optimal grouping of objects into collections is determined by the workload. So that brings us to the second part of this presentation is how should we model that? How are we going to reach our solution? So we just talked about identifying the workload. So that's going to be the first phase of our methodology. Once we identify the workload, we're going to go and establish the relationship, identify them, model them. And then finally, the third phase is going to take care of applying patterns. That's going to give us this extra performance boost that we may need in order to meet these very tight SLA or these like meet the throughput and everything that is related to performance, for example. So if you pay attention, if you have experience with a relational database, you probably saw that right away. Usually when I work with a relational database, I take care of the data model first, and after I go write a code, and some of the things may make me change the data model. So I basically do the workload identification secondly. With MongoDB, and not just MongoDB, with all the NoSQL database, because the world has changed. It's not, again, because it's MongoDB. Now we have amount of data that we didn't have in the past. So it's much bigger. So performance comes to your mind much earlier in the process. So what we need to do is really identify what's going to be the workload. Once we know that, only when we have a good understanding of it, that we can come with the best data model. So we're switching the two phase, basically. Okay, so let's detail a little bit more that first phase. We want to size the data, how many entities we're going to have, how big they are. That's going to give us a good understanding of the capacity for the disk, the amount of machine we may need, etc. We're going to quantify the operations. What are all the writes and reads that come true, and what are the key numbers I need for those. And we can also qualify those operations. There may be other aspects, especially for very important operation that we want to know, like security, archiving, a little bit more on that later. So here's an example back to our social network for chefs. We're going to have some write operation. For example, we have new articles. They're done by the author. We don't have that many of them per day, maybe 10. And then we're going to have all the other users are going to come and comment about them, 10K, so it's no much larger number than, obviously, the writes we get for the main articles. And then read operation could be all our users coming in and reading things. So we estimate that, at scale, we'll have maybe 10 million of those per day. And then there's also analytical queries that need to be done. This last one, we don't have many, but they do have an aspect that's very different, So when you have an analytical query, it's going to go and scan a lot of data. That may not be the best thing to do on your primary node, so you may want to have a different node that's going to be able to accept those kind of queries. But listing those is going to help you make those decisions pretty early. Now, the thing you're going to realize when you write all those queries is that one's going to come and dwarf the rest, or two. So they're likely the one that you want to pay more attention. And if you have a very small system, you probably don't need to list all the operation. If you can identify the most important one, that's going to get you, a long way. If you have a large system with a lot of different people developing with you, you probably would want to have a little bit more details there. Anyway, so out of that, it's pretty clear in our example here that we have a query that we need to have fast, because that's the one that people are going to be reading the information. So if reading the information is too slow, they'll probably go somewhere else. So you take those important queries, and then you list a little bit more information about them. For example, the latency. So it's not just the throughput. Latency is often like the most important thing. If this thing doesn't answer in 10 milliseconds, maybe I don't have a tool, the website that people are going to be interested in looking at. Another interesting thing is the data lifespan. We see that very often with all the financial companies that we work with. They have a requirement to keep the data, for example, for 10 years, but they're not going to query it after 3 years. It's usually just for audits. So if you write that down, what you want to do with it, that's going to be important, and you can make the right decision. And you may also have other requirements like GDPR, the right to be forgotten from the European standards. On the opposite side here, you're going to see a way to capture that information. That's been added to a tool that I like, Accolade, one of my partners on the book. And if you use that tool to model, you can capture all the information about your queries. So this came out as the collaboration for the book, so that was great. Okay, so out of that phase, what we get here is that we can best act on new hypotheses if we know the original hypothesis. So the goal here is to write things down, because we get it wrong. It's not going to be perfect. It's going to change. No one can estimate for sure perfectly what's going to be all the queries coming and the rate and all that. So what we're trying to do is write it down, and when we start observing things, if things are different, that's going to be a good indicator that we have to go back and revise part of the model, because the numbers really don't match what we expected at the beginning. So once we get out of that, we have a good understanding of what we're trying to do. So we're going to go and model the relationship. So the different steps in that phase are going to be identify the relationship first, quantify them, and then embed or reference. And that's going to be the most important query, most important question you can answer in the whole data modeling methodology, if you're going to embed information or reference it. To illustrate the concept of relation, how it's applied to a tabular database versus MongoDB, let's take the example of a car. So at the end of the day, I come back home, I take my car, and I want to put it in the garage. If I was with a tabular database, I would store all the wheels on the shelf. I will store the seat on the shelf, the brakes on the shelf. And then in the morning, I would go and reassemble all the parts and get them out. So that's the application. When it needs data to reassemble everything from the different parts from your relational database, and then you're ready to go with your data. When you work with MongoDB, All the parts that are used together are stored together. We're not going to break them apart and reassemble them. So what we're saying is, and this is probably the most important principle of everything I'm going to say today, what is used together in the application is stored together in the database. That's, if you want one rule that's going to help you do a good design, that's the one you should remember. Okay, so what would be the rules that's going to help us decide, should we reference or should we embed? But before we go there, I just want to be sure it's clear to everyone what I'm talking about. So in a relational database, if you have two tables, they're reference. You have foreign keys, and that's how you identify how to go from one piece of information to the other one. In MongoDB, you can do the same. You can have the information into two documents. It could be in two different collections, one collection, but in two different documents. And you can have a reference to the other one. And you can either join it, application time, or you can run it, join it using the $lookup that we have that's going to be done on the server, which is basically what join does in a relational database. But we also have another option. And the other option is to embed. Embedding means out of my two tables, one table is going to be put inside one document through an array. So if you look at that, the array is really the instantiation of a one-to-many relationship. So I talked about quantifying earlier. So this is an example here. And again, this is not because it's MongoDB. It's because the world has changed. We have much larger databases. When you describe many work, in the past for a while, but now many can have, a lot of different ranges. And if you don't understand those ranges, maybe you're not going to make the right decision. So what I like to use is three numbers. What's going to be the minimum value for that relationship? It's going to be the maximum, which you get, in a regular, you get the minimum at least, 0 in a relational database, in typical ER diagram. But we also put the most likely. So when I see that, I'm going to get a minimum 0 comments, a maximum of 1,000, which means I may block more comments after that, and the most likely 50. And that gives me a good indication if I should embed the things or not. If there's too much information, you probably don't want to embed it. That's what we're going to see in the next rules. So the rules that's going to make me prefer referencing, when the many side of a relationship, one-to-many, is very huge, that means that the array would be huge. It probably means that I'm not using all that. Back to our concept, what is used together, stored together. But things are not used, maybe you don't want to store them. So in that case, referencing may be better. If I want an integrity, the integrity on the write operation for many-to-many, I don't want to have to update many documents when one change, for example, one information about the name of the author. So in that case, I could just keep things separately. That said, if you have many documents, you want integrity, you can still use a transaction. Transaction works pretty much like in relational database, which also means they're not the most efficient thing. So in MongoDB, your most important operation should not be using transaction. But other ones that you need to keep consistency, no problem, go for it. And finally, when a piece is frequently used, but not the other ones, a large document, I'm using something, not everything, and memory is an issue. Memory is not an issue. We have only 100 of those documents, no worry. Memory is an issue, then it may be better to just split things apart. Okay, so the opposite, when should I embed? Integrity of read operation for data that is read together. Again, you can use a transaction, but the document is per se atomic in MongoDB. You can write to it, you can read to it, it's always guaranteed to be atomic. And that brings us to the second one, and integrity of write operation on one-to-one, one-to-many. There's no data duplication. That's going to be done better if you embed. For data that is deleted or archived together, and that's a good one that I discovered this year. And especially working with banks, they had to archive documents. Think about that. I want to archive the account of a customer. After 3 years, put it somewhere else where it's going to be slow storage. If I try to archive the different pieces from a relational database, it's going to be a nightmare. If the document is self-content, that's what document model is. Its joins are already realized inside that one document. I can take this one document, archive it, and this document, if I read it 5 years later, it still makes sense. It has everything it needs. It doesn't need to do a join at another time to get my information in the current state. And finally, the last rule by default. It goes, if you embed, your system is going to be simpler usually, because it's going to match the object you have in memory. So if you're not sure if you should embed a reference, you should probably default to embedding. So out of that second phase, now we have established all the relationship, we decided where things go. Some may not clear, should have embedded or reference. Maybe I don't feel I have the right performance to achieve something. And this is where the pattern is going to come into the picture. So we have 5 different groups of schema design patterns. This year, the 16 patterns have been revised for the book. So the book is really the last incarnation of the software design patterns, the schema design patterns. I'm going to quickly go through some of those, but obviously, this is a very short presentation. I don't have time to do that. An example one is called the extended reference pattern. It's the case that's in between referencing or embedding. I was not sure which one to do. Well, what you could do is still keep the 2 pieces of information separate, but enrich this. Instead of just having a pointer to this piece of information, add some fields, like the name of the customer, to avoid having to do joins for your most important query. But you need the details, then you can go fetch it. So this one's called the extended reference pattern. And in the case of, for example, here is, yeah, I'll keep with the article the ID of the person who wrote it and the name, but everything else about the person that I keep, I don't want to update that in every article. But the person name is unlikely to change, then I'm okay. I can put data duplication is pretty easy in this case. Computed pattern, this is going to be extremely useful for performance. When you do queries, you don't want to be recalculating things over and over, especially when you have a lot more readers than writers for a piece of information. In that case, when the piece of information changes, for example, a new comment is added, let's just compute the number of comments, put it there. I don't have to compute it for every person who's reading this article. The subset pattern, an example would be, I don't want to keep all the comments associated with the article. So what I'm going to be doing is just keep 10 of them. All the comments will be somewhere else in the collection, but when I load my article, I can show you at least 10. It could be the 10 most relevant, the last 10. You choose, but you don't have to do another read and pay the price for information that the user may never go and get. And finally, the schema versioning pattern, which is going to be the topic for the last segment of this presentation. How do we evolve the model with the schema versioning pattern? Well, the first thing, any successful system will go through changes, likely including data model changes. 2 types of changes mainly. One is we change a table. That works very well with relational database, alter table and all that. And then the one's a little bit more complicated is modifying a relationship. So I have a relationship that's one-to-one, and I want to change it to one-to-many, for example. So I may have to create a new table. And that's what we're going to do. That's the example we're going to do here. So if we go back to our example, this is the version 1 of our schema. We have users, they have a home phone number and a work phone number. But then we have a new user who has a little bit more information on how to reach him. That's Alton Brown. And we realized, well, we really want something flexible where, we can start adding Skype, WhatsApp, and everything as mode of communication. So we're going to create this one-to-many relationship and remove the original columns. If I have a relational database, it will probably look like that. On Friday evening, I have version 1. Going to bring the system down. I'm going to migrate the data into tables, and then I'm going to reopen the system. Now, let's do the same with MongoDB. So this is the new document we would like to fit. It doesn't really work with our version 1. So I'll say version 2 should be like that. We're going to embed that one-to-many relationship as an array. It could be 2 different collections. It'd be exactly the same thing. So the key here comes from versioning the schema, not the document. We're not versioning the content, the values I have in the document. I'm versioning the shape. When you're in a relational database, you get to have one number for the whole schema. So if you try to change the schema, every object now has to be changed. With MongoDB, we're going to piggyback on the fact that we have polymorphism. We have objects that are different. Some objects can have a field, the other ones don't have it. They may have a different type. One may have an array, the other one doesn't have it. So we're going to use that version number in every single document. So on Friday evening, I have my 3 documents in version 1. That's what I want on Monday morning. Now, I can go and migrate the documents one by one, as long as my application was changed first to understand the 2 shapes. When it reads one of the shapes, it knows how to display it. It knows how to do things on it. I don't have to have downtime. So MongoDB not lets you just develop and deploy quickly, but also evolve your application and schema quickly. Which means if you need to change your schema, you can do it in a clean way without downtime. So it's a great benefit versus a system that's not going to age well because you're not doing the right modification on it. So in conclusion, so we divided the presentation into 3 sections. We talk about the need to model, some of the principles we got out of that. It's imperative to know the feature of the products you're using. The optimal grouping of objects into collection is determined by the workload. Then, for a methodology to model from MongoDB, we say, well, you have to write things. We can best act on your hypothesis if we know the original hypothesis. And what is used together in the application is stored together in the database. And then, using the schema versioning pattern, we deduce that any successful system will go through changes, likely including data model changes. MongoDB lets you develop and deploy quickly, but also evolve your application and schema quickly and cleanly. So if you want to know more about that, we do have the book, MongoDB Data Modeling and Schema Design. There's a series of blogs on patterns and anti-patterns. So in the next months, I'll be updating some of the patterns to include the new ones that we've described in the book. And we have MongoDB University. We have 2 main classes, I will say, that touch data modeling. The first one that I'm going to point to is the second one listed there, M320 data modeling, which we're redoing and should be coming in the next month out with a new version of it. So this one goes through, the schema design pattern and everything that I've talked about today with obviously a lot more details. We also have another class. First, how many of you here are using MongoDB University? The class? There's quite a few, but that's not enough. We need a lot more. If you don't know, MongoDB University is totally free. We're not trying to make money out of that. We want to be sure that you guys are successful in using our technology. So we're training you, and there's no catch. So you can go do the classes for free. So obviously, you should register. It's learn.mongodb.com or university.mongodb.com. So that second class I wanted to point to is for those of you who've been using relational database for like 20 years and you're not sure, you feel a little bit lost with MongoDB. Is that a good technology for me? Do I have to start learning from scratch? And the answer is no. Everything you've learned with relational database, a lot of that translates to MongoDB. At the end, it's just another database. So what we're trying to do in this course is about 1.5 hours to 2 hours of content. It's very easy, no homework. We're trying to match your knowledge that you have from what you were doing with relational database to MongoDB. So if you don't know where to start, that's a very good course. And today we have some other presentation also that's going to help us get more information on data modeling if you want. First, there's a great one. It's called From RDBMS to NoSQL Enterprise at Scales by Rick Julian. Rick is a fantastic presenter. I would certainly, if you don't know him, I would certainly go there. And Rick and I will be together at the end of the day, the last session, right before you can get a free beer. So I'm going to try to not go over time there. But we're going to have this Ask Me Anything panel. And we also have with some of you, we have some design reviews. I'm not sure. I think we're booked for the day. But we will be back. Do I put it there? Yeah, on August 29th, there's a MongoDB Developer Day here in Chicago where we're going to go and have workshops and different things. So look for that. It's another event that could be very interesting for you. On that, this is the QR code to leave your comments, your review of that presentation. I'm not sure if there's something after. I don't think. Thank you for your time. So I'll leave that here if you guys want some. Thank you.